A prism is a transparent optical element that reflects light. There are different types, but we're going to talk about dispersive prisms. They can be used to break light up into the colors of the rainbow. Furthermore, prisms can be used to reflect light or to split light into components with different polarizations. Our modern understanding of light and color begins with Isaac Newton. He was the first person to understand the rainbow. In the late 1660s, he starts experimenting with his celebrated phenomenon of colors. At the time, people thought that color was a mixture of light and darkness, and that prisms colored light. Hooke was a proponent of this theory of color and had a scale that went from brilliant red, which was pure white light with the least amount of darkness added, to dull blue, the last step before black, which was the complete extinction of light by darkness. Newton realizes this theory was false. His prisms demonstrate dispersion, the division of white light into its component colors, and also the recombination to make white light.
Light changes speed as it moves from air into the glass of the prism. This speed change causes the light to be refracted. The refracted index of many materials varies with the wavelength or color of the light used, a phenomenon known as dispersion. This causes light of different colors to be refracted differently and to leave the prism at different angles, creating an effect similar to a rainbow. This can be used to separate a beam of white light into its spectrum colors. If light inside the prism hits one of the surfaces at a sufficiently steep angle, total internal reflection occurs, and all of the light is reflected. This makes a prism a useful substitute for a mirror in some situations. Newton's experiments demonstrated that all the colors already existed in the light because particles with different colors traveled with different speeds through the prism. Newton arrived at his conclusion by passing the red color from one prism through a second prism and found the color unchanged. From this, he concluded that the colors must already be present in the incoming light. The prism did not create colors, but merely separated colors that are already there. The result of these experiments dramatically transformed the field of metaphysics. Newton's prism faced several problems and was not accepted straight away. Within a year of his announcement, Robert Hooke argued that diffraction is not a new type of refraction, as Newton had claimed, and that it could only be explained by assuming that light is a wave. Many other members joined Hooke in criticizing Newton's particle theory. Some denied that Newton's color spectrum existed. Many other members joined Hooke in criticizing Newton's particle theory. Some denied that Newton's color spectrum existed at all, and others denied that his 44th trial really proved that light is not composed of waves. It was not until 1676, 4 years after Newton's initial publication, that he performed more trials and gave people enough information to be able to replicate them. Newton stated that those who failed to replicate his experiments must have been using bad prisms.